This lesson is High School Geometry, Similarity, Right Triangles, and Trigonometry, C8. Today we will use trig ratios and the Pythagorean Theorem to solve right triangles. The Pythagorean Theorem is a squared plus b squared equals c squared. And let's review trig ratios. So since this is angle theta, we know that this side is the adjacent and this side is the opposite. And the slant will be the hypotenuse. So it's crucial to remember SO, GA, TOA to help you remember all the trig ratios. So the S stands for sine of theta, which equals opposite over hypotenuse. The C stands for cosine of theta, which equals adjacent over hypotenuse. And lastly, the T stands for tangent of theta equals opposite over adjacent. Question 1. You know an angle and the adjacent side. You want the hypotenuse. Which ratio should you use? So let's begin by drawing a triangle. This is a right triangle and we know this angle theta. So this would be the adjacent side and this is the hypotenuse is what we want to find. Pause the video and try to figure out which ratio has all three of these elements. So, remember SO, TOA. Sine involves the opposite and hypotenuse. Cosine involves the adjacent and the hypotenuse, which is what we're looking for. So, we should be using cosine to find out the hypotenuse. For question 2, let's find each of the variables. So we know that angle A equals 42 degrees and side A equals 8. So let's use tangent to find side B first. So tangent of 42 degrees equals opposite over adjacent, which would be 8 over B. Let's multiply both sides by B and divide both sides by tangent 42 degrees so that we isolate the B and that equals B equals 8 over tangent 42 degrees. If you put this in the calculator, you will get 9 and we'll round to the nearest whole number. So we know that B equals 9. Using side A and B, we can find side C with the Pythagorean theorem. So 8 squared plus 9 squared would equals 145, and we'll take the square root of that and round that to the nearest whole number, and that will be 12. So C equals 12. Since we know all of the sides, to find angle B, we can use any of the ratios. Let's choose cosine. So cosine of theta equals adjacent over hypotenuse, which is 8 over 12. To input this in the to find theta, we'll take cosine, the inverse of cosine of 8 over 12, and that will give us 48 degrees. We can check if this is correct by adding angle A, angle B, and angle C, and that should equal 180. So 42 degrees plus 48 degrees plus 90 degrees is 180 degrees. So we are correct. So angle B would equals 48 degrees. So for problem 3, pause the video and try it on your own first. So after you've gotten your answer, let's solve it together. So we know side B and side A, so we can try to find side C using the Pythagorean theorem. So 5 squared plus 12 squared equals 169, and the square root of that is 13. So C equals 13. Since we have all of the sides, we can use any of the ratios to find angle A and angle B. So let's find angle A first. So angle A, since we haven't used sine yet, let's use sine to solve angle A. So sine of angle Sine of theta of angle A would be opposite over hypotenuse, so that would be 12 over 13. Again, to find theta, you'd find the inverse of sine of 12 over 13, and that is equal to 67 degrees, rounding to the nearest whole number. For angle B, we'll do the same thing. So sine of theta equals opposite over hypotenuse, so 5 over 13. To find theta, take the inverse of sine, and we will get 23 degrees. And to check if this is correct, we can add 90 degrees, which is angle C, plus 67 degrees plus 23 degrees, and that equals 180 degrees. So angle A equals 67 degrees, angle B equals 23 degrees. C, which is obvious, is 90 degrees. You will be completing question 4, the extension question, on your own. A tree casts a shadow 40 feet long. Find the height of the tree if the angle of elevation of the sun is 35 degrees. I will help you with the visual to get you started. So let's draw the tree here. This is a tree, and we need to find its height. So the sun is up here, and the angle of elevation, this angle is 35 degrees, and we know that the shadow is 40 feet. So we're trying to find this